Okay, let me go back one step.
Some man in Germany.
So I said we are starting a new topic which is called elastic load balancing. And before we go deep into, or before we start talking about elastic load balancing, I want us to first look at how websites work. So how does websites work? Well, let's go deep. Let's go straight to it. When you ask majority of people how websites work, you will hear different people with different opinion. But the layman that has a little bit of IT knowledge will tell you have a user that has a laptop. And when the user when the user wants to access any website, he opens a browser, and let's say the website he wants to access is the cornelis.com. The user is going to open a browser, any of his choice. He's going to input the cornelis.com on that browser, and immediately they press enter. What happened? The website showed on their system. So it can go further by saying, well, this is a request and a response activities there. There's a request and a response activity. Like the user make a request to see a website, and then the laptop or the browser responded back with the website. Well, that is absolutely true. For a layman, that is good. But for you coming into the cloud, it's not that you have to know more than that, but it's always good if you have a more concrete knowledge of what actually happened behind the scene. So let's take it further for a more complex and advanced IT guy. You have a user that wants to access a website. When you open a browser and you type in the Cornelis. What happened is that the browser that you opened and you type the cornelis.com, the cornelis.com that you typed, or the domain name, that cornelis.com is called the domain name. That is only known to you, the user, and the person that owns the website, and what we call the domain name server. So what the browser will first do is that it will go to the domain name server. That is a server that has a table or a book that map the IP address of where the server or where the website is hosted, and the name that they give to that website. Like I give the name the cornelis.com to the website. That is the name of the website. But that website is actually on a particular server. So that server that website is stored on is using an IP address. It has an IP address. And anytime you want to locate any resources, or you connect any resources or any device to the internet, they have their own address. The address is like their own home or house address, just like everybody have their own house address. If I want to locate you, all I just need is for you to tell me your house address, then I can come there. The same thing with all devices that you connect to the internet, they have IP address. And anytime you are communicating from one computer to one computer, or you are calling one phone to another, you are sending traffic to the address, which is the IP address of the second device. So, but the second device, because it uses an IP address, if I give you the IP address of the cornelis.com, then hardly you will visit that site, because how many people has time to be memorizing IPs, numbers? So because people know that, okay, numbers are difficult to memorize, then instead of giving you that IP address of that server, we do what is called mapping. We map that IP address to a name called the cornelis.com, google.com, yahoo.com. We map those IP address to a name, then we give you that name so that it can be easier for you to remember. That mapping, the name to the IP address, is actually stored on the DNS server, which has like a book or like a table that it keep all those information. So if you open a browser on your system and you press google.com and immediately you press enter, that browser, before it goes to Google to go and get their web page, it will first go to the domain name server and ask this domain name server, what is the IP address of google.com? Then the domain name server, having those information, we look at the google.com in its book and we trace it to, okay, find the IP address of google.com. Then it will respond back to the web browser the IP address of google.com. So it is now the IP address that browser will use to make a call to Google server. It is that IP address that you will now start using. Immediately the DNS name, the DNS server gives the IP address of google.com, the browser will drop google.com. It will now start using that IP. It will use the IP to make the request to that server. Then when that server wants to respond, it's going to respond back to the browser. Then the browser will display the information on your system. So this is what happened behind the scene. When you press google.com and you press enter, the browser first go to domain name server and a request for that IP address of that server, of that domain name. Then you send the IP address back to the server. Then the server will now start using the IP address to trace the server. Because on the internet, all the devices on the internet, they use IP to locate each other. If one device wants to locate another device, it's going to use IP. So once the browser gets the IP address of the host, of this host, then it is now that time it will start using that host information. It will start using that information to respond, to communicate to the browser. And the browser, once immediately it tells the browser, hey, can you send me, or this user one, this person here is requesting the index file of your of the cornelis.com. Then the browser will now send those files to, the host, the server will send those files to the browser. Then the browser will now display it in form of graphic. That is when you now see google.com and you think that everything is right. In between this communication, there is also other things that happened, but which we're going to leave for now till another day, because the DNS we also send information to another thing. Like, then let's go to that route now. But main thing that you need to know now is when you press google.com or the cornelis.com, yahoo.com, facebook.com, those are just names for you to easily, we call them user-friendly name, for you to be able to remember that host. But behind the scene, that name is actually an IP address. So when the browser wants to get those files, is going to be using the IP address, because that is the only language they use to communicate on the internet. They use IPs. So now that we have how IP works, how the browser works, if one person is requesting the data, if one person is requesting, maybe only one person is on your website now, and that person sent a request, then you respond because they already talked to the DNS, and the DNS has provided the IP address, and the browser uses the IP address to talk to the server. Then the server sends the website. What happens if instead of one person now, multiple people are now want to access the server? Well, the same process is still going to happen. Those users, they will still open their website, their various websites, and the whatever browser that they opened on their website, we still need to communicate to the DNS server. Then the DNS server is going to provide the IP address of that website, and then the browser will use that IP address to talk to the server. That is still normal. But the problem here now is that we have multiple people trying to access the same server. So if this server, like we said earlier in auto-scaling class, that if this server is just meant for like few people, and now we have a lot of people, then that same issue that we have doing auto-scaling will happen, because this server is going to collapse. It's only meant for like 10 people, and now you are seeing 20 people. Or it's mainly only meant for 20 people, and now you are seeing 100 people. So it's going to collapse. So what can we do? Then we can also scale up or scale out. So if you are scaling up, there is no problem, because we're still going to be the same server with the same IP address. But if we are scaling out or horizontal scaling, that means we are going to be adding another server with a different IP address. So now is the problem. How are we going to map this IP address to the Cornelis name, cornelis.com? Because if we just spin up a new server and it doesn't get mapped to the cornelis.com, then all the users, they will still be accessing the same server, because the cornelis.com can only be mapped to a single IP address, except if you do something like redirect, and which we are not going to, which is not something that is easy that way, and some company will not even want it. We only do redirect, maybe to a protocol or something like that. But let's say we are not doing redirect. So when a user, when we spin up a separate server, so that when we scale up, when we scale out, the new server that we create is going to have a different IP address. So now that IP address, if these users, they want to communicate, they want to view the cornelis.com, they will still, all of them, even if you like, let's also have 5 servers waiting to handle requests, because it is only this server here that is mapped to the cornelis.com. All of them will still be coming to that single server, even if you like have 5 different servers currently running. So how can we undo this process, that instead of all of them going to this single server, and that's why we have multiple servers? Are you getting me? So here now, if we have these multiple users, and all of them, if you have this multiple user trying to access our website, and we have, even let's say we have 5 different servers, what still happen behind the scene is that indirectly all of them will still be accessing the same server, because the remaining servers are not connected to the cornelis.com. You can only connect one server to the cornelis.com, because you map an IP address to a domain name. The cornelis.com is a domain name. I'm looking for a pen that I can use to annotate here. Let me see. Okay. Let me use this. So if you can see my screen, this Cornelis.com here, can you see this red line? Let me know if you can see it. Does it annotate?
Yes.
Yes.
Okay.
Yes.
This Cornelis.com here that we have here, it's actually mapped to only this IP address. So when we have multiple servers, all these users that you are seeing, because this Cornelis.com here is mapped to this IP address, all these users, they will still be talking to this server. That's why we have multiple servers, because this server here is not linked to anything. So now the question is, how can we make these users, instead of all of them sending traffic to this server alone here, how can we make it possible so that they can distribute their connections to different servers? So all of this is kind of complex when you have when you are manually managing your server this way. So this is what happened when all the users are accessing the same server. So there is something we can do, and that is called load balancing. Load balancing. So what we need to do now, instead of all the traffic going to one, despite we have multiple servers, we can have something called a load balancer, which is another server that will be listening to that request. All it does now is just listening to requests from the users. It's going to be listening to requests from these users. So these users here, they are not sending their request directly to the server, to either this or this. They are not sending their request to any of that. But what they will now be doing, they will be sending their request to load balancer. So the load balancer now will now be the one distributing that traffic. So what does that mean now is that none of these users has access directly to these two servers. And also, we can now have what is called a consistent distribution of traffic. Initially, when we don't have a load balancer, do you know what will happen? If we let's assume that we are able to connect all of this together, let's assume that all the users, they have access to these two servers. So one particular user might prefer this, the other one might prefer this, and the remaining user might prefer this. So the workload will not be distributed equally. So with the help of the load balancer, they don't have access to any of these instances. But what they have access to is the load balancer. So the load balancer will now know which of the server is going to be sending the traffic to. And the load balancer too can know when a particular server, let's say this server is out, then the load balancer will know, then it will stop sending traffic there. It will now be redirecting the traffic to only this one here. So with this, we can now make sure, or we can now ensure that we have a consistent distribution of traffic. And when a server is down, then we are not faced with the issue of customers sending traffic to a server that is down already. So the only place this customer will be sending their traffic is this load balancer. And then the load balancer will be distributing this traffic. Does that make sense? Does that explanation make any sense? If you guys do not answer, I'm going to call somebody.
Yes, sir.
Wait, Tina, are you a man? I hear yes, sir, but it's you that show up.
No, I didn't say anything.
Chima no sound like Tina.
Oh, okay,
Yeah.
because I saw Tima, then I hear a man's voice.
Chima, your name shows as Tina.
Yeah.
Yeah, actually,
oh shit, my bad.
actually, I have a question though. I don't know if
All
it's
right,
part
go
of
ahead.
it. I'm just
Go ahead.
curious.
Go
Just
ahead.
curious. When you have like, I'm trying to figure out like when you have like, for example, your website, the Cornelis, and you have like, let's say 10,000 people trying to access it. How is it
Okay.
actually programmed? I get from the back end side of it or whatever to actually be popping up pages when you have like 1,000 people trying to access it. I'm just curious of that. Does it
Go ahead.
like is there I don't know how to ask. I don't know how to ask the question. I don't know if I'm asking it the right way, but like, how can you have like 1,000 people trying to access the Cornelis website at the same time, and like the whole process where like, I mean, like
Yeah,
everybody's getting the same web page. Everybody's getting the same web page at the same time.
Okay, so just see that as you have one person holding multiple books, and if you have 5 people in front of that one person that is holding multiple book because he has like 5 hands, then if you say you want to see book 1, it will show it to you. Then while it's showing it to you, another person that say wants to see book 1 too, they have access to see it. It will still show it to them, right? Then other people, if you say you want, and this third person say you want to see book 2, then it has 5 hands, then it's going to show it to them. But if that doesn't answer your question, this is how it works. We have the cornelis.com, and you have multiple users. Every user that is trying to visit cornelis.com, that is what we call traffic. That is what we call traffic. So when you go to cornelis.com and you open it like this, it sends a request to the cornelis.com. Then when Tina also go to the cornelis.com, it send a request to the cornelis.com. And if 1,000 people send requests to the cornelis.com, then it send 1,000 requests. But all those requests, it now depends on the server that you have. If it only have like a laptop which has one CPU, then all those requests will queue. And that is when you will see that at times when you respond to, when you were searching a server, it's spinning, then what actually happened behind the scene is that if that server is not powerful enough, that is why server is more powerful than laptop. So server can respond immediately. You just click, it's just going to send response back to you. When another click, is send response back to them. And when we get to solution architect, we are going to simulate auto scaling, whereby you will see what is called a CPU utilization. And those CPU utilization is as a result of people or traffic that a server is responding to. And you will see the number of CPU utilization. That means the number of traffic that it is responding to, and the CPU that it is using to respond to a particular or some traffic. So what actually happened behind the scene when you multiple people visit website is that the website is listening to requests, and as you come, then it send you response. As you come, it send you response. Servers are used for this, and it's extremely fast. It's extremely fast. So if you go to the cornelis.com and click a browser, you click home page, it's going to send a request with what is called a HTML method. The HTML method, when you click something like this, next, it's going to send HTML. Sorry, that one I'm using is bad. I don't know where I put my pen.
Hypertext markup language, right?
Yeah,
hypertext,
yeah. HTML is going to send. Sorry, not HTML. HTTP. What I mean? It's going to send HTTP. but this is a protocol. So it's going to send what is called a HTTP GET, meaning that, hey, I'm sending you through browser, but what I need is that I want to get something. Then it's also going to specify which of this file that it wants to get. So if you want to get about us, you will say get about us. So what that means behind the scene is that this is the message that the browser will see. Then it will know that, okay, this person wants to get about us. That is where it will send the about us file to your back as a response. Then when that file gets to your system, the browser will open the about us on your system. But any button you click here is just you are sending a traffic to a server.
Okay.
All right. So now we understand what a load balancer is. So now let's move this to the cloud. AWS have a load balancing service called AWS Elastic Load Balancer. AWS Elastic Load Balancer. So with this load balancer, it's exactly what I explained. It does exactly what I explained earlier. It helps to distribute traffic to multiple servers. So now the load balancer has as a single point of contact for incoming requests, just like what we saw the other time, that multiple users, they don't have access directly to the server, but they only talk to the load balancer. So the load balancer now, which is AWS Elastic Load Balancer, it now serves as a single point of contact for any traffic that is coming in. So the request that is coming in, or the requests that are coming in, they first go to the load balancer. Then the load balancer will take that request and will now distribute it among those instances. So it has as it automatically distributes traffic across multiple resources or multiple instances. It's not only EC2 that you can use load balancer for. It's not only EC2, but it's actually one of the common resources that you use load balancer for. So there are multiple load balancer with multiple AWS load balancer, which we are not going to talk about them. Just know that AWS have a load balancer that listens to requests and distributes it. When we get to solution architect, then we're going to be going deep into load balancer, and there you will see multiple different load balancer, which we have application load balancer, we have network load balancer, gateway load balancer, or classic load balancer, but I'm not going to go into that route now. So load balancer works together with auto scaling. So both of them, they communicate together to make sure that we have highly available environment. The auto scaling group will spin up multiple servers when we have a lot of traffic. While load balancer will take those traffic that are coming in and distribute it among the servers that the auto scaling group creates. So you can see both of them work together. But before we go to see the other thing, okay, let me first finish this. Let's look at the relationship between the two of them. Let's look at the relationship between the auto scaling group and the load balancer. So as I say, auto scaling groups handles the workload infrastructure, which I explained earlier, while the load balancer distributes traffic among those servers in order to prevent inconsistent distribution of traffic among the server. So 1 second, I think I do not arrange. Yeah, there is a slide I'm missing. I don't know if it's somewhere there. There's a particular slide I'm missing. Let me see. Yeah, I think I'm missing the slide. Yeah, I think I have a diagram. Maybe I accidentally delete diagram. So I was showing a diagram of how the application load balancer and the auto scaling groups work. But that is not a problem because, as I said earlier, we're still going to discuss this in depth when we get to solution architects. Your takeaway is that now you know how all of these start building up. You start from what is computer, then you know on what a server is now, you know what a database, you know different services that you can use as server on the cloud, which is EC2, and you know how you can scale your EC2 using auto scaling, and you know how you can distribute resources among those servers. This is, you are getting into cloud gradually. So this is virtually everything that, well, not everything, but you become, before you know it, you are already a solution architect, because majority of this is, we come out under solution architect. Then all you just need to do is just to learn little more about them, because we are not really going in depth about them now. We're just introducing the service. Now let's look at this knowledge check. So now we are going to pick which of these service is auto scaling, and which of this service is which of them would be auto scaling and which of them will be load balancer. The first one ensures that traffics are distributed among servers. Which
Load balance.
Load balance.
what? Load balancing?
Load balancer, yes.
Let me see who is not talking.
Yes, load balancing.
Yes, load balancer. Your load balancer.
Is Victoria in the class?
Load balancer.
Okay, I'll start calling him. I've never heard Victoria talk before. I never heard Sophia talk before. I never heard Adeoti before. Ade, I've never heard.
Mensch, der hat ein Aquarium, der hat ständig über seine Fische gesprochen.
Okay, auto scaling, right?
Gut.
Load balancer, okay. The second one had, my English is bad there, had a second EC2 instance doing an online spike.
Auto scaling.
Auto scaling.
Studies for over 50 years. So there was nothing on his computers. They had those pictures.
What is the question?
Such
Second one, yeah.
Your reputable supplementaries. Do you know exactly what you need people on the coffee table? What is it, Bobby?
Please, once you finish answering the question, please just mute again. If you know that you are watching movie behind, we don't want to hear the movie you are watching. But if you want to talk, just unmute yourself. Adjust EC2 instance to match predicted traffic flow.
Auto scaling.
Auto scaling. Adjust.
Adjust EC2
Auto scaling.
instance to match.
Auto scaling. No.
Auto scaling.
Auto scaling.
scaling.
Who say load balancer? Let's that person.
Auto scale.
Okay. Auto scaling provides a single point of contact for incoming traffic.
Load
Load
balance.
balancer.
Load balancing.
AWS load balancing.
Remove instance when not used.
Auto
Auto
scaling.
scaling.
Distribute workloads across available.
Load balance.
Load balancer.
So does that mean you understand what auto scaling is and what load balancer is?
Yes.
Yes and yes.
Yes. Yes.
Okay.
Yes.
Okay. All right. That is the end of auto scaling and load balancer. Now let me stop the video